Okay, let's take a gander at example 1b. So we're going to solve this the exact same way as example 1a. So I'm going to, step one is you need to draw an imaginary line between 2 points on the two different chords. So we got chord ED, and then we have chord BC. So either draw an imaginary line between E and C or B and D. I'm going to do E and C since there's a little more space to work with. So I'm going to draw an imaginary dotted line here. And we can see that where we formed a triangle. We got this point, and this point. Not only did we form a triangle, E here and here, we formed a couple inscribed angles. So the first is we have this inscribed angle DEC, right? So the measure of angle DEC, which again is an inscribed angle because it's sitting, the vertex of this angle is sitting on the edge of the circle itself. What's the measure of angle DEC? Well, we know that an inscribed angle is half the measure of the arc that it intercepts. DEC intercepts arc DC, right? Because DEC starts at D, the angle's at E, then it jumps to C. DEC is 35 degrees. So that means the measure of angle DEC is half of 35. So 35 divided by 2. Okay, and that is going to equal 17.5 degrees. So DEC is 17.5 degrees. Now we can look at this inscribed angle. We can look at BCE. The measure of angle BCE intercepts the same arc BE, right? So arc, we're jumping back and forth between angles and arcs. So just make sure that you're paying attention to what I'm saying. So arc BE, the portion of that circle from B to E is 28 degrees. Well, the inscribed angle is going to be half of that. So BCE is going to be half of 28, which ends up being 14 degrees. So we've got this angle, we've got this angle. That's all you need to solve for this angle of this triangle that we drew. We know, sorry, let me put this down as 28 divided by 2 is equal to 14 degrees. So to complete the triangle, the measure of angle, we'll call it EGC. So this guy right here is going to be 180, and it's 180 because the three angles inside of a triangle add up to equal 180. So 180 minus 17.5 minus 14, and that's going to leave us with whatever's left over, which is going to be this angle right there. So let me just starting to run off the page just a little bit. Let me do that. Okay. So 180 minus 17.5 minus 14 is 148.5 degrees. So this angle right here is 148.5 degrees. 17 and a half, 14, 148.5. Now how does this tie in to this x degrees right here? Well, we know that a straight line equals 180 degrees. So I have this straight line. So let's try to visualize. Let's take away. We solved for all this, so we know this is 148. Let's take away all the rest of the circle and let's just look at this little section right here. So we have a straight line, and it's kind of being intersected like this. We know that this is 148.5, and we're trying to find this x. And again, I just imagine me taking a magnifying glass, and I just have this magnified. So we're just looking at this little piece right here. Okay? Straight lines are 180, which means x is going to be the total 180 minus 148.5. So x is equal to 180, which is the total, minus 148.5. So now I'm taking this away, and that leaves me with whatever x is. So 180 minus 148.5. So my answer is 31.5 degrees. So x right here is equal to 31.5 degrees. Now, I showed you how to solve these. We can look at example 1A and 1B and notice something. And that's what the next portion of notes is going to include. So what pattern can we notice? And this is right below example 1B on your notes. We notice that x for both examples can be found by, let's see, x, let me write this in black so it's a little bit easier to see. X can be found in both examples by adding both arc measurements and if this is loud, my wife is watching something in the other room and it's pretty loud, so I apologize for that if you can hear it. So x can be found by adding both arc measurements together and then dividing those by 2. So 2 is what's going to go in that. So adding and 2 go in those 2 blanks. And we can test that. So for example 1B, we had these 2 arcs were 28 and 35. So 28 plus 35, and then dividing those by 2. So what's 28 plus 35? 28 plus 35 is going to be 63. And then if you divide 63 by 2 in your calculator, you'll see you get 31.5. That was our answer, wasn't it? Let's look back at example 1A. We had 120 and 40. What was x? Well, let's see if that works. So 120 plus 40 divided by 2. So 120 plus 40 divided by 2. 120 plus 40 is 160. 160 divided by 2 is equal to 80. And that was the answer that we got. We got x to be 80. So this drawing the imaginary dotted line, it's good that you know that's where this came from, but whenever you solve these examples, just know this is what you need to really focus on. X can be found in both examples by adding both arc measurements together, then dividing that by 2, and that will give you this x value.